All right, you're going.
Well, welcome to the January 25th, 2022 session of Tangerine SDR and HamSci technical session. My name is Dave, KV0S, and this week I've been working on reconfiguring computers, which I'm doing on a project working with JB, and frustratingly, most of the things I was trying to do didn't work, but today I got it all back the way it was before I started. So a frustrating weekend, but I got everything back working. So that's about it for me. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Steve. I've just continued working on writing more reports and getting things ready for the HamSci workshop. And I participated in the contest this weekend, which was great fun. And getting ready to start classes again on Wednesday, and things are going to just keep going. So back to net.
Very good. Next on the list is Dave, KD0EAG. Go ahead, Dave.
Oh, well, hello, everyone. I have not been, as usual, doing anything terribly remarkable. I guess I've been playing with, I don't know if you can see these little things, LoRa stuff, trying to seeing what I can do with low power data collection. But not much related to this. So that's it for me.
Okay, next on the list is Bill, AB4EJ, right? Bill? Your mic's muted.
Okay.
There you go.
How's that?
Yes.
How's that? Okay. Well, I've been working on some stuff on the NASA project, but since we got to talking about the potential impact of the Tonga explosion on the ionosphere, and let me see if I can figure out how to show this. Here is a view of the reaction of the ionosphere. It was several hours after the event, but it's the best we could do with looking at the data on 20 meters. Let me see if I can bring it up. Okay, here it is. Screen 2. All right, do you see that?
Yes.
All right, see, there's a very clear transient ionospheric disturbance. Now, compare that to what it was like on a typical day, a few more typical days. That is, that's a typical day right there. But you can see the dramatic difference. Let's see, it disappeared. Let's see if we can get it back again. Okay, there you go. So even though the event was out here at 0400 Zulu, you can see that the ionosphere is still ringing 10 hours later. Now, is that due to Tonga? Who knows? But it is an interesting coincidence if it is coincidence. But I think there's a chance that really this is the ionosphere still ringing 10 hours later, even after the event took place at 0400 Zulu. You still see these very nice TIDs 10, 12 hours later. So anyway, that's what we're looking at. And what we're looking at here is on the x-axis is time, and on the y-axis is spots and the distance. So you can see how the distance of spots reported on PSK reporter varies over time The color indicates the amount of spots, and the y-axis is the distance of the spot, this distance of the contact in kilometers. So, I mean, that's an example of what we're working on for the NASA project, but I just wanted to do a quick look and see what it looked like for that day, the 15th, when the Tonga event occurred. So anyway, that's what I've been doing, and mainly I'm working on the paper for that. So anyway, back to Nick.
Very good. Next on the list is Bill in 8 ET. Go ahead, Bill.
Yeah, my main event was the contest this weekend. Had a good time on that, and Work Nathaniel kind of surprised me, and I'm only got half the call when he called in, and I didn't realize who it was. When I got the rest of the call and put it all together, it got me all screwed up and logged, and so it took me a better part of 4 or 5 minutes to get that tangled up, but finally got it straightened out and got on the way. But had a good time. It was first phone contest I've done in about 9 years at any kind of effort, and didn't set any new records, but had a good time. I think that's about it. I was thinking I had one more thing to say, but I'll wait. If that comes up, I'll say it later on. So back to you.
Okay. Next on the list is Dan in 4XWE. Go ahead, Dan.
Okay, thanks, Dave, and good evening, all. Worked a little bit on trying to put together a demo for Hamcation. I think we're going to do an FT8 demo of some sort. Did work a few stations on FT8, even down into South America. I had a contact in Ecuador and another one in Argentina. The bands are a little spotty, a little fadey, but all in all, they are really booming certain times of the day. The muff was up into the 12-meter band, which is a little bit higher than it has been as of late, like for the last few years. And that's about it.
Well, very good. Sounds like interesting. So next on the list is David McGaw in 1HAC. Go ahead, David.
Good evening, everyone. Guess radio related, I've been working on our Baffin Island project. Hoping to get that up sometime soon. And I guess I'm working on both pools because also I have a humans project for Antarctica. And an interesting thing came up that might relate here is that we're looking to put a chirp sounder down there. And they're asking for a lot of power. And I'd like to see maybe ultimately with the personal space weather station doing that work, maybe we can keep the power down to a dull glow, shall we say. Guess that's back to net.
Well, fine business. And next on the list is David Waugh, KE8 QEP.
Well, hello, everyone. So I did participate in the QSO party, and I didn't register with Gary, which is probably good because I only made one contact. Because I can only use, as a technician, I can only be on 10 meters. And oddly enough, it was to Washington, which is from Ohio, is probably about as far as I could get in CONUS. But so that wasn't great, but HAMSI related, being in Northeast Ohio, I was able to procure, or I haven't gotten it yet because there's been a lot of snow, but there's a lot of HAMSI people in Northeast Ohio. So via Bob Benedict and John Gibbons, I can get a new board that can be converted to the remote board, so I can get my magnetometer up and running when the ground is unfrozen. That's it. Back to Dave.
Okay, very good. Next on the list is Gary AF8A. Go ahead, Gary.
Yeah, good evening, everyone. I wanted to thank everyone who got on the air for the contest this weekend. Some stations made over 600 contacts. David, you made one. Ben W1 BPM, he also made one. So we had a pretty good spectrum there. The winning team, so to speak, were the Hamside Grapes. Myself, Bill NADT, and Brad WF7T put in a really strong effort too, which pulled us ahead of the group. So anyhow, it was nice to see all that posted. And Word Silver suggested that I write something up either for the National Contest Journal or perhaps the ARL contesting newsletter about Hamside and how we put our teams together and what. So I'm considering doing it. I'm trying to pull something relevant and be interesting to the rest of the contesting community out of what happened last weekend. And maybe we'll get a little paragraph here or there about it. That's it.
Fine business. Sounds like a successful endeavor. So next on the list is Hyomin Kim, KD2 MCR.
Hey, good evening, everyone. Just as Dave mentioned, yeah, I've been working on many different projects. One of the major project is the Antarctic project, where we will be installing a suite of instruments being relied on the local power source, which is solar and wind. On the science side, using the magnetometer data, I'm trying to look at wave activity in both hemispheres, interhemispheric responses to solar activity. So the question for you guys is whether we can have some Hamside personal space weather station participation from the Southern America, so that we can have magnetically conjugate observer. That would be really nice if we can involve someone down there. We know that having something in Antarctica is not realistic at the moment. So I think if we have some kind of conjugate network between North and South America, especially slightly at higher latitude, like maybe Canada and upper states in the US, and I guess Argentina, Chile, I guess, that can be conjugate network. So that will be another interesting project, because interhemispheric observations of geospace environment is now picking up a lot of interest within the community. So that's something that we can talk about later as things develop. So back to Nat.
Sounds good. Next on the list is James, KG4 DSG. Go ahead, James.
Good evening, Dave and the group. Not much to report here, just listening as usual. I did post a link in the chat, interesting animation of a atmospheric pressure wave spanning out of the Tonga eruption. Not ionospheric, but atmospheric, and it was taken from a space sensor. It's kind of interesting to see. With that, back to the net.
Fine business. And next on the list is Jim, K4 BSE. Go ahead, Jim.
Good evening. Well, I've been spending some time also on the data from the 15th. If I can share mine real quick. Are you seeing it now?
No, not yet.
Okay, why is it not there?
Now it's sharing and we got your Zoom login.
Okay, now you should have the data.
There you go.
Okay, good. This is the data. I started with the day before, the 14th. And it turns out there was some interesting stuff that happened that day too. And I'll just take 8 people have sent me their data, and I'm expecting 1 or 2 more. So what I'm doing right now, this is the data from the 14th, and below it will be the data from the 15th. I've just put this on the same scale, and these green vertical lines are every 5 hours, just to make it easier to keep track of where you are on the graph. And this is what I found interesting. Well, let me skip to the 15th to begin with. I won't take too much time on this. The data for the 15th is the same, except I've laid in here the time of the earthquake. And you notice that just about everybody does have this same kind of effects during the day. On the 15th, it kind of wild compared to what a normal quiet day is. But what's curious is that there is a lot of stuff before that too. Starting at about 1100 hours on the day before. Here's one representative one. Starting at about 2200 hours on the day before. We did start getting some wild stuff, which I had assumed was a different phenomenon altogether, and wondering how we could separate the two, if indeed there is any relationship. But I mentioned this on a local 10-meter net just an hour ago, and one of the other guys on that net, who happens to be my neighbor, said he remembered seeing in QST a few years ago about the possibility of using HF propagation to predict earthquakes. And now I'm anxious to go find that article he referred to. He thought it was more than 2 and less than 5 years ago. So I'm anxious to find that article and see if there is any thing to that and anything that might be useful here. So that's about all I had right now. Back to Ned.
I may be able to identify that paper. I'll see if I can find it.
If you can find it, I would appreciate it. And let's see, I was interested in Bill's information too, and see how that goes and how that might factor in.
And Jim, I realize we're supposed to be going in order here through the check-in, but is there a way to automate the GRAPE upload data? I know there's a site now it can go to, but like with the magnetometer data, you could automate it to go to Dave's site. Do I just need to manually drag it over? Is that what?
That's what I have been doing.
Okay.
I don't know whether there's anything. I know John has come out with some more recent software that I have not looked into for that yet. I'm not sure what its capabilities are, but unless he's got it in there, I'm not aware of anything.
Okay.
I'm looking at an email from John Gibbons from January 22nd, and he has some new software.
That's what I'm referring to. Yeah.
Expert 2 repo. So it looks like they might have that capability coming up, but I wasn't able to make last week's GRAPE Telecon on Thursday. So I will be interested to know exactly what this is.
And I haven't had a chance to download that and try it yet.
Yeah, that's getting close to working. Part of the issue was they didn't want to overwhelm the WWV repository. So Dave Schwartz asked us to kind of move slowly on that whole thing and just
Right.
a few people at a time. So that's moving forward, but we're not quite there for everybody yet.
That is correct. Yes. Thanks, Gary.
As far as your earthquake propagation, I've got a name of a fellow. I get an email every day that lists all the earthquakes around the world, and it's from a fellow that did that original paper. He's a VE, I think VE7.
Yeah, there's a lot of issues with his science. So I would be very, very, very skeptical of what he's saying.
That's interesting. Yeah.
Okay. So there absolutely there are connections between radio propagation and earthquakes. Certainly, I absolutely believe that you can see these traveling atmospheric disturbances after the earthquakes. And, I've pointed you to some good papers like that. But and there are some peer-reviewed papers, I believe, that do show some evidence that do talk about precursors to earthquakes in HF radio. But I would be very, very, very skeptical of the things that you see from the other author you're talking about.
So I want to jump in here and remind everybody there was some solar activity during that weekend as well.
I tried to find some data on that, but I haven't found much. Can you refer me to that?
It would be the NOAA space weather site.
Yeah. Space Weather Prediction Center.
Yep.
I think I looked at that and didn't see it.
Well, there are hundreds and hundreds of pages there. You got to spend some time finding your way around.
Okay, thanks.
You can certainly find what the K index was back a bit. Also, I'll remind people that there was some activity on this subject after the big Japan earthquake and tsunami. That was observed in the ionosphere. So I'm sure there are some papers one could go and search for on that one.
I'd like to see that.
If you go searching for these things, I recommend you go to scholar.google.com. And I try to pick things from more reputable journals. So all of the American Geophysical Union journals, including Journal of Geophysical Research, Space Physics, Geophysical Research Letters, Space Weather, Radio Science. That would be a good material. The European Journal is Annales Geophysica. That's a good journal to go to. Atmospheric measurement techniques. But if you go to scholar.google.com and you look at the peer-reviewed resources, I would trust those much more than what you. What's that?
I'm sorry, I didn't mean to interrupt, Nathaniel. But wouldn't like various algorithms that people or stats that people use for financial analysis in the stock market and whatnot, I mean, it seems like there's so many data sources that could be looked at for correlations. I'm sure that has all been worked out. I mean, I couldn't possibly do it, but
just a comment, in time series analysis, what you're talking about here is very complex, multiple harmonic sequences. And that makes it much harder to do a nice clean time series. It's possible, but it's not trivial. Putting my statistician hat on.
I think so. The problem with Alex Schwartz's analysis and the earthquakes is he will come on every day and he'll say he'll show you a plot and he'll be like, all of these things are being caused by earthquakes, and he doesn't take into account any other possible mechanism that is actually more likely, because there's a whole body of literature. You can pick up the Davies Ionosphere book. There's lots of very good propagation reviews online. You can pick up any of those things, and there's lots of well-known evidence of how solar activity affects the ionosphere, how geomagnetic storms affect the ionosphere, all these other things affects the ionosphere. And what Alex will do is he'll go on and he'll just say all these things, they just correlate with these earthquakes, and he doesn't do any careful analysis of it. And if anyone tries to say, ask him questions about it and say, okay, have you considered these other things? Can you explain to me exactly what you did there? How are you actually proving this? He gets very flustered and doesn't actually answer your question.
I think maybe the word is defensive.
Defensive, yes.
Yeah,
And
I can confirm that. I actually saw him speak a week ago on this very topic.
yeah,
And while there's probably some very good stuff there,
mhm.
I think Nathaniel's correct that it isn't well parsed scientifically.
And he's gotten like Phil Erickson, who's the associate director at the MIT Haystack Observatory. He's gotten into like tiffs with him over his scientific method. So that's why I'm saying I really wouldn't trust his work. But
Nathaniel, given this is being recorded, should we be really critiquing individual scientists?
this is a well-known.
Okay,
Okay, this
I trust your. I
Yeah.
get a little uncomfortable.
So no, I'm not trying to be disparaging. I'm just saying I would, you know, you can do some searching on the internet and you can see that there's a lot of discussion about this. And
Oh,
this
no,
has
and
been,
I don't doubt your critique. I just
Yeah.
There are plenty of peer-reviewed papers out
Yeah.
there as well.
so what I'm recommending that people do is that if for this particular topic, you know, try to stick to the peer-reviewed literature. So if you go to scholar.google.com, look for things that actually have undergone the peer review process, that aren't just preprints, and try to look for things that you know really explain their methodology well. Look for things that propose a good physical mechanism, and there's a lot of literature out there that shows what happens after an earthquake or after a tsunami, where you can see these traveling atmospheric disturbances go through. And that was the paper that I shared last week, is a review of all of those things. In terms of precursors, predicting, that is, there are some things out there, but it's not as well explored. It's not as well understood. That is definitely, you know, it's a much more open question. Yeah.
Can I interrupt that we have 4 people still waiting to say something and then we can open it up for everybody? So next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, Dave, and everybody on the group here. I'm just sitting here looking at my grape recording for the 15th, and boy, it was all over the place. And of course, Jim has a copy of that. But the grape is still recording data from WWV. Been doing some very short range radio frequency tests, and that's pretty much it. Back to you, Dave.
Okay, fine business. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I had a busy week this week. I spoke to Trimble support on that PPS jitter issue that I had with my Res SMT 360. I'm still having it at intermittent times, and there were 2 other engineers that were on the email, and their general consensus was that it is related to marginal reception, but they didn't want to say that, you know, but they kind of hinted it. But they emphasized a temporary fix to get me up and running. They wanted to. They mentioned that I should use a better antenna, probably dual frequency. So I said that you know, there's an L1, L2 antenna that me and Nathaniel have to put up. But they did assure me that they are working on it. So I don't know if it's going to come in the form of a firmware update, or if that's going to be the end of it. I'm not really sure, but I'm hoping that the L1, L2 antenna being outside clear view of the sky will hopefully fix that problem, because if the PPS starts to jitter, it will not record data. It won't output data to the buffer. So I would lose things. I would lose amateur transmissions, natural events. So I'm hoping to get that hooked up as soon as possible. I also sent an email to John Gibbons about what exactly he did to the FLDigi software, because I was exploring the possibility of using VLFRX tools to take the place of FLDigi and generate those same plots and the same data. Christina attached a paper that gave some more technical detail on it, but I just want to see what John says, and maybe obtain a recording, like a day's recording, and try to reproduce the data that FLDigi does. So that's something that I'm going to explore. I also had a discussion with Jules about isolation of the magnetometer. What we were doing was we were looking at different sorts of circuits, and I found a very low power 0.25 watt DC to DC converter that is isolated and should do the trick. It's from XP Power. I use XP Power DC to DC converters in my VLF receiver, so they work pretty well. He also found an IC that couples data through capacitive coupling, kind of similar to the way that Linear's some of their A to D converters do. So that's an interesting thing that I'm going to try to work on. See if I could come up with a separate isolation boards, like a pass through for people that would need it. This way, the design won't have to be changed. There'll just be these isolated boards that people can build or whatever, and that'll give them the isolation that they need if they need it. We also discussed, we were on the discussion of seismographs with the Tonga eruption in everyone's memory. I was telling him about a 3D printed seismometer called a hammerhead that I was working on. I currently don't have access to a 3D printer, and I was working to try to have someone print out the parts. There's like 14 parts, but it's a vertical seismometer that's supposed to have the same kind of performance as the professional ones. So we were discussing that, and he may be able to actually print out the parts for me. Lastly, there was a lot of discussion about VLF amateur activity on the Dreamers band, and I was looking more into Paul software, a mode called EBNOT that is used to transmit messages, well, mainly characters, over the ULF bands with very low power, and through use of error correction and parity. And to actually transmit, you could actually build yourself a rig with a Raspberry Pi and a GPSDO, and you know, you could have a full rig for the EBNOT mode, and all you would have to do is connect the output to a power amp and then to your antenna. So I'm actually going to work on a full-on rig in an enclosure with you know, bulkhead jacks and everything that you'd need to have a full-on EBNOT transmitting rig. And I would like to show that off at Tapper if possible. Lastly, I opened up a VLF IRC channel. If anybody uses IRC, I idle on there regularly. It's on libera.chat. It's number sign VLF if you want to join. Other than that, that's all I have. Back to Minute.
Well, fine business. And next on the list is Michael, AAK. Go ahead, Michael.
Oh, thank you. Jonathan, the interesting challenge will be your antenna. Greetings to everyone listening. Back to you, Dave.
Well, fine business. And lastly, we have Scotty, WA2 DFI. Go ahead, Scotty.
Okay, can you hear me okay?
Yes.
Okay, just still been working on the adapter board, getting close now to having the regulators substituted, since I'm having a heck of a time finding regulators that are in stock. So, but I think I found all we need, and we should be, I'm gonna guess, going into CAD next week or this week, because my CAD guy is finished with the other project he was on. So now I've got him chained down to work on our project. So get probably see if I can get Tom to help review this board, and anyone else who's interested in seeing it, you're welcome to take a look at the schematic and critique it, and before we put it down into copper. So that's what we've been doing this week. Back to you, Dave.
One last question. Has anybody heard from Tom recently?
No. I'll be writing him this week, so
okay,
we'll see what happens.
Well, tell him we miss him.
Okay, I will.
So, that is the list, unless I missed somebody, and 16 tonight, and we're open for general discussion.
So that sounds like really good news, Scotty.
Yeah, I think so far, everything I either have in stock or I can get. So that was kind of the goal of going through this thing again and making sure that I can build it, because there's not a lot to it. The connectors are the biggest problem that I can't really get, but I have them for the data engine. So I will pirate them from that. I'll order them and then pirate them from that. And the lead time on the connectors is only like a month or two. So if you believe them, you know, we'll have them back in before we get the FPGAs in. So
it's only a month or two.
Only a month or two.
Only.
When I look and I see 2023, I get discouraged. But when I see only a month or two, I'm excited. You know, that's quick.
Yeah.
So yeah, in fact, if you want to take a look, I've got a kind of a layout. Hold on a second here. I got a mechanical, I won't say, it's just a drawing that I put on the first page that I like to give to the CAD guy, so that he doesn't have like no place to go when he wants to build the board. So when he has to start with an outline somewhere, so you got to tell him what it is. So I give him this, and then we hack on it, and he says that's impossible or that's easy or whatever, and then we go from there.
Mm-hmm.
So let me, if I can figure out how to do this here. Hold on a second. I got to get the cancel that. I don't like computers. Keeps making this thing full screen and it covers over the thing that I want to show off. So it's like, put that over on a different, you have 3 screens and that's not enough. That's bad. Okay, now let's try this again. How about here? Okay, does that work?
Yeah.
Yep, we see it.
Okay, so the idea is there's the data engine on the upper left with the clock module and the leaf module mounted to it, and the 2 RF modules mounted underneath it. The RF module is here separate, the clock module here separate. And then the Max 10 development kit that we all have is right here. The outline's right here. And then this is the development board. I'm sorry, the adapter board with 1 RF module plugged on behind it and the clock module plugged on top of it. So the idea is, and then this is kind of a side view. So the development board card is right here, the upper one, and it plugs on, the HSMC connector plugs right on to the dev kit, no cables or anything, it plugs right onto it. And then the RF module plugs on the bottom of the adapter card. And the clock module plugs onto the top of the adapter card with the normal M2 connector. And these are rough approximates of the size card will be. We'll have to tweak it a little bit, but this is what you need is you need this tab here to get past the Ethernet connector because this is tall. This is a double high Ethernet. So the board, and this is only like 10 millimeters off of the board. So you can see that the Ethernet connector would be way up here like this. So we have to notch the board out like this. And the RF module is 100 millimeters or 110, 115 tall. So we got to be able to do this. So these are probably going to stick out a little bit, which is okay, but we want to make sure we get the holes in the right place so we can bolt the RF module right onto the adapter. And by the way, this hole is moving over to the middle over here, lined up with this connector. And so we'll move that over and have it. In fact, you know what? Let's just move it right now.
Seems a little out of scale to the.
It's way out of scale. This is meant to be just a rough place the stuff here kind of thing.
Okay.
And to show him where the main components go so that, and it's up to him to make this fit. So
Scotty, just for your information, you just made a change. The board on the side, you need to make the same change.
Oh, thank you for that. That would be
Yep.
Again, this is very rough, so it's not the whole. I mean, I put the hole here. He did the clock module, so he's gonna go to the clock module data and get the location of that hole and align it properly. So this is again, just say, hey, make it look kind of like this. This is what I have in my mind as to how I want it to fit. And then he could tell me, well, this is impossible because such and such is in the way, or this will work, or let's make the board this size, maybe make this bigger. We might end up making this go up and overhang more and things like that. But the main connections are between the HSMC and the clock module, and the HSMC and the RF module. So we may actually slide this downward to give him more track space in here to do routing. Not really critical, but the point I wanted to make was that I can get both boards plugged on is the idea. Is we can use this adapter board to test both modules. So that is the idea.
That will be great.
Yep.
I think this is doable because it's not looking very complicated. I just wish I'd gotten my button gear a little earlier, but I think we can get all the parts, and that's the exciting thing is I haven't built anything that I could get all the parts for in a long time. So it's.
Hey, Scotty, I think I missed something important. On the left, in the upper left-hand corner, is that like the actual layout, and the right-hand one is the adapter, or?
Yes, this is the data engine itself that we've already laid out. But we can't get the FPGA, so we're going to make this adapter board to take the place of the data engine and still plug the clock module and the RF module on it to test with a off-the-shelf dev kit.
Right. Okay, that helps. Yeah, perfect. Thank you.
That make it more clear. Yeah, it wasn't. If you don't have that background, it'd be hard to understand what we're doing. But we're basically, since we can't get the FPGA here, we're going to buy, and we actually, most of us already bought this development kit that has the FPGA on it. Now it has fewer pins, but it's the same core that we use. So that means that whatever code we come up with that runs here we can port directly to the data engine when we get the data engine finally someday, we're all still alive. And of course, the data engine will have space for 2 RF modules as opposed to 1, and there'll be a leaf module connection, which there is not going to be on this. Sorry, Jonathan. But I couldn't really find a way to put the leaf module on there.
All right, this is a clever workaround. You did something pretty good.
Well, I hope it works. We're gonna get off, try to get off the dime here, and instead of feeling sorry for myself and not being able to buy parts, I could do something, you know.
Yeah,
And,
that'll be very important.
and the cool part is that we actually got an ARDC grant to do this. So we have
Very good.
money to pay the layout guy to actually do the layout. So
Scotty, with your trip to Hamcation, will that take a week out?
this should be, I'm just going to say this will be done before that trip.
Oh, good.
So we will probably, I'll have, well, I'm going to have my parts person be buying parts now. I mean, like as soon as I get this done, so that we can make sure we have them. And like I said, I really don't want to pirate parts from the dev kit. I mean, from the data engine if I don't have to,
Right.
Because I don't want to make that, you know, unbuildable. If miraculously somehow the FPGAs come in, then I'm stuck again. That would be stupid. So I'll try to avoid that, or at least we may borrow some parts but replace them. That's okay, as long as we know that we can get those. And so I think with any kind of luck, cross your fingers, I might actually have one of these boards by HamSci.
That would be amazing.
Yeah, so we'll have something to show off. And even if I don't have the other 2 boards, you know, if I have at least something to show, or one of the 2 RF module or clock module, or maybe even just first examples of the boards without any testing, because I know Tom and John are going to want to do their testing on those 2 boards.
Mm-hmm.
And they're going to need some FPGA support. So I want to get this done, and I'll be working on the FPGA probably by the time I go to Hamcation. So
If you bring it to HamSci, make sure you have at least one LED that blinks "Hello World." That'll be good enough.
blink hello world in Morse code, right?
Right.
That's right.
And I know a guy that back in the old days, they used to have this chess competition at the computer fair. Anybody remember San Francisco Computer Fair, West Coast Computer Fair, spelled FAIRE?
I remember it, never went there.
It was in the 1980s. Anyway, they had a chess competition, and they had 4K, 8K, 16K microprocessor competitions, classes of computers that people built to play chess. Okay. So my friend built the one in the, I think it was in the 4K class. So remember, this is 4K of instructions, and it was done in assembly code. And he had the chessboard was laid out with coordinates, you know, X and Y coordinates, and his code, you're gonna love this, his code was in RAM. So when he turned the thing on, he had to type the code in with a keyboard manually, 4K worth of code into this box, because there was he didn't have ROMs then, you know, it had only RAM. And then if you turn the power off, you got to do it all over again. So of course you keep the power on for as long as you can. Probably had battery backup so he could do that. But what I remember the most about the whole thing, not the chess, not how well it played or anything like that, but the fact that what he did for typing in the code, the instructions, is he read out the hexadecimal values in Morse code so that he could type on the keyboard and not have to go back and look at look to make sure that he typed the right thing in. So he didn't have to watch the screen, or, well, he actually didn't have a screen. Oh, he's sending characters, but then as the machine gets the character, it sends it in Morse code. So what he can do is he can put his hand on and get this is a hand assembled program, right? He didn't have an assembler. So he hand assembled it and typed in the opcodes in hex and hand assembled it. And then he could put his hand on the sheet and go down the sheet and type in with his fingers and listen for the code that went in. So if he made a mistake, he could fix it. And it was like a great example of like 3 senses, right? Sight, hearing, and touch that he's using to input the code much faster than he would have to if he had to go here and then go here and then go here and then go here.
Well, I was going to say, using a keyboard, that's cheating. You have to do it from the switches.
Yeah. Yeah, okay. I'll tell him you said that.
Absolutely.
Yeah.
I've done it.
He would still be doing it.
Yeah, so like if you had like an Altair or one of those with all the
Oh,
switches.
even, yeah, well, even some much newer computers, we would patch machine code in from switches.
Yeah. Well, this is pretty slick because it was on a board like, like yay big, 5 inches square, maybe, or 6 inches square. The keypad was about half the board. The pad where the pieces went was the other half with numbers marked on them. And then a little buzzer or a speaker for the tone. And that's it. That it was just, I mean, what's 6 inches square? It's like a Tangerine board. And I think he used a 2650 microprocessor. If anybody remembers that, I think it was a Signetics processor. Can't even buy one anymore, I'm sure, because it was very short-lived. But so enough reminiscing about projects past. It was just an interesting use of Morse code to read the thing out. So I'm sure we could find a similar use. So, and maybe what I should do, since I have some extra IOs, I should put like a hex display on here or something, just to have it count or something, so it can do standalone. It can do something that is like you said, it has to have an LED or something blinking or counting or do something. Hello
Well,
world.
you need a speaker for feedback, and then you need a microphone so you can put the code in by Morse, by just voicing it the Morse
Code
code.
decoding. We just took the paddle up to the FPGA and you can paddle it in.
There you go. Yeah, you paddle it in.
Yeah, well, okay. But I might add some LEDs. That's a good idea, just because if I get it done and nothing else, at least it could be a Hello World hardware equivalent,
Yep.
Well, make it a tricolor so you can make fancy rainbows.
I was thinking of, I could never make this in production, but I have some little 4-digit hex. They're alphanumeric, or actually they're hex, so they only do 0 through 9, A through F, but they take ASCII in. So you got like 7 inputs and a strobe and an address, two address bits, and you can load the LED display with whatever you want. It's like a 1/10 inch high display, a little bitty thing. But I only have a few of them, so I couldn't really put it on the board and use it for anything. So the beta testers wouldn't get it if I use that one. I should probably pick a production one so I can put it on all of them. So even like 2 digits of 7 segments would be enough, right? I mean, you could count with that.
Mm-hmm. Yeah.
So, okay. That's it.
Looks good, Scotty.
Let's hope that we can make this work, because it looks like it will.
I hope so.
If I need to have one of these systems with the dev kit in order to test the local host, how am I going to, what am I going to do there? Because I see that they're not in stock anywhere.
I have 2 or 3 dev kits, Bill. I'm sure I can give you one.
2 or 3. Okay, wow, you an embarrassment of riches over there. Okay, good.
Yeah, and I have 2 or 3 of them also. Tom, I think, also has 2. And I have a secret source, which I won't name, that I can get another one from if we run short.
I have one.
Okay.
Dave, you have one, Dave?
I just have one.
Dan has one. Somebody else has at least one.
I have one.
David
Dave has one.
Well,
Yeah,
everybody
when we
has one.
Yeah.
Yeah.
I can give you one, Bill.
Okay.
We'll make sure you get one. Don't worry.
Because they've got long lead times even for the dev kit now. So
yeah, well, remember when the 25 kits came in, and we bought them all out in about 2 days. So I don't know that we got all 25, but I think we contributed heavily to their demise.
I think I bought I think when you told us about that one night, I bought two that while we were on the call.
Yeah. And I already had two and I bought another one. So I think there's three of them around here. So I have two available for anybody. So we should add up how many we have and see how many prototypes we actually have to build, because there's not really any point in building prototypes for boards we don't have, right?
Correct.
And so, Bill, have you looked to see, is that board that's like big, long lead time?
Yeah, I was just looking at, let's see.
'Cause I think
DigiKey,
Mauser and DigiKey both sell them.
Mauser has a September 2022 lead time on them, and DigiKey, it doesn't even say what the expected reception time is on them. So
Okay, let's see. There's one other place that might have them. Well, okay, I don't really care if you're closed for Chinese New Year, because I'm not going to buy today.
Doesn't McDermott has at least one too?
Tom, I think, has two.
Two.
So maybe he has at least one. So, okay, let's see. Cyclone, no, Wax 10. No, they don't even list it on their website anymore. That's not a good sign. But Jurassic is the one that makes it. So sometimes they have stock when no one else has it.
Scotty, did you have trouble fitting the leaf module on that little board?
I did not fit it on there.
It doesn't look like it would fit.
It's not, I haven't implemented it. I'm not going to do a leaf module for this. We're going to wait for the DE for that.
All right.
So that's why I was apologizing to you for not having a data module, but can't you use a Raspberry Pi for your initial testing?
Well, that's the plan. I have the evaluation module. That board, I don't believe would fit either, because that has a single high-speed data connector.
Right, and that's the problem, is you can't really fit both the clock module on that because the whole back is taken up with the RF module. So it's not really possible to do that. It's not big enough.
Yeah, I mean, it could fit off of the, one of the edges of the boards, but I don't know how the routing is.
Yeah, and I'd have to look at the amount of IO that I have, because on the HSMC connector is limited. That's why we only get one RF module.
Oh, that's right. Okay.
So I have to make sure I have enough IO to do it. And so I was really not considering that was a, because it's really, this is designed to test clock modules and RF modules.
Right,
Boards
yeah.
that we already have or will have within, as soon as we build them. And I've been holding off building them because there's no point in building them if we got nothing to plug them into, but now we will have. So we can go ahead and build those, and we have all parts for those. So no more waiting around for that. We managed to sneak them in under the wire. And I'm looking, I do not see. Oh yeah, here it is. Let's see. The M10K. Yeah, stock, contact us. So who knows? You have to contact them to see if they've got any. I'm talking about Jurassic. So looks like the three places that we get them are all sold out. So
I don't think that's a surprise, though, is it?
no, it's not. What I was surprised at is that we could get them at all at the first place.
Right.
Yeah, I don't even see, it doesn't even come up here on DigiKeys. It's kind of hidden on DigiKey's website because they have a bunch of other Max 10 boards. 50.
Yeah, I found it on DigiKey and it says lead time not unavailable.
Is this the one that they raised the price to $218? Yeah,
Yes.
it is. They raised the price. Check lead time. Yeah, right. Not available.
Right.
Well,
Not
it's
surprised.
unavailable. If it's unavailable, they should drop the price.
That's right. When I don't have it, I sell it cheap. You
That's
know,
right.
Well, yeah, the ship date estimate is not available.
it's just
It's actually $219, but
yeah.
$218.90.
So let's see. Oh, come on. They really want to make it hard for me, don't they? Maybe just Max 10 DK would be enough. One hit. And it's the right one. You can still purchase this product for back order. Like you said, July. 25 expected July 7th, 263 expected July 21st, 95 expected August 5th. And I don't believe any of that. Because remember that when we were ordering them, they had a lead time of, they were expected delivery was like the next week. And next week came and next week went and they didn't have any. So fortunately, DigiKey had them and we bought them there. Long lead time reported on this product. Yeah, right. It's like that's true on every part. Oh well. We'll work around it as best we can. So Dave Waugh, did you say you did not need this the new magnetometer board or replacement for yours?
Yeah, through my local Northeast Ohio contacts through Bob Benedict and John Gibbons, I think I have procured one. I haven't picked it up. There's been a lot of snow here.
Okay, which one did you get? Did you get one of Dave's, or did you get a Tapper one?
I don't know yet. I think it's one with the RJ45 going in the wrong direction.
Yeah,
so
that's
I'll
like this
solder
one.
that out.
Off the side. Well, that's useful. Anyway,
Yeah.
it comes down this way.
Yeah, so I think I can pull that out. I haven't seen it in the flesh yet.
Yeah.
Um,
Can tell
but-
mine are orange and Dave's I think are purple. So if he uses the same screen, he could address that. But
yeah, well, I'll find out and let you know.
okay, yeah, if you need, like I said, it's been sitting here waiting for you to tell me whether you need it or not to ship it out to you. And if
Okay,
you haven't,
no, that's great. I'll see what Bob has and go from there.
and if you haven't determined the cause of failure, I'd like to take a look at it before.
Oh, well, and I'll send it back to you. I did try cleaning it up because I was going to try to see if I could fix anything. And a few of the, and I was very careful cleaning this, and I have experience cleaning irreplaceable fossils with very small Q-tips and whatnot, and a few of the resistors fell off along with the solder pad. So I think
so it got underneath the copper and ate the pad right off the board.
Yeah, and I think that it had been leaking for I don't think it was just one event that killed it. I think it was slowly leaking, but once I saw the solder pads lifted off,
Yeah, usually that's the death knell for, I mean,
Yeah, I
you
was
might
like,
fix it with extreme effort, but it's usually just not worth it.
but I'll send it back to you just so you can look at it.
Okay, yeah, because I have Dave's killed board, the one that he got wet. And it's,
Yes,
put it in the museum, you know.
yes.
He has a resistor actually standing up on end on his side. I mean, so I don't know how that ever happened, but because Dave, you didn't mechanically wash that or do anything to it, right?
Nope. I sent it to
So-
you the way it came out of the tube.
So I have not looked closely enough to see if maybe the pad came loose and it's twisted and hanging by the trace or what it is, but the resistor is vertical on the board. It's bizarre. When I saw that, I said, okay, that's it. I can fix almost anything, but I don't think this is worth it.
Yeah.
I'd rather build him a new board.
Well, guys, I'm going to say 73. I need to go.
Yeah,
Me
I would say
too.
the same thing.
Likewise.
Yeah, just a report
Same
from
here.
here.
Yeah.
Nothing new this week.
73.
Oh,
you know,
Jules, did you just come in?
Jules?
Yeah,
Jules just came.
I came in kind of late, sorry. Nothing new this week. I'm just working on the temperature control chamber for above ground mounting of a magnetometer. Other than that, pretty quiet. I've been communicating with Jonathan about some ICs, and other than that, fairly quiet.
Yeah,
See
and
you next
by
week.
the way,
Yes.
Jonathan, I got your ICs, your A to D converters. I don't know if I told you that. We got them a long time ago.
Yes.
The TI ones that we ordered that were back ordered, remember?
Yeah, the 6140s. Keep those safe in your sock drawer. We'll use them later on. I think probably the best direction right now would be to do a Raspberry Pi or BeagleBone Black sound card to test out the IC that
Okay.
way in the application. That would probably be the best course of action, don't you think?
Yeah, yeah. I don't want to, I'm trying not to hold you up any, but I don't see any way I can get the leaf module in on this adapter, so.
Yeah, I mean, even
Can you stand it on its end, straight up or something?
Can't really do that, but we could, like he said, we could. I mean, the board's free form. I mean, we could double the size of the board and stick it on there if I have the IO to do it. So let me look at that and see.
Well,
what I can do.
the board that the eval board, that's actually a little smaller than the leaf module. It's about the same size, but it's a little smaller and it's already built and made up. So all you'd have to do is just add the appropriate connector, you know,
Okay,
and
so let me do this. Tell me what IOs you need and what kind of connector you want. And can we use like a ribbon cable to connect it? Is it that kind of connector?
No, it's one of those board to board connectors. It has like 20 some small pins with a center, you know, like a ground plane.
Oh, yeah, like a Mictor connector.
Yeah.
Oh,
It's
those
used
are
by
fun.
Samtech.
So, okay, well, again, send me that connector type and let's see. I may be able to just run it over to the edge and hook some wires up to it, and then you'll be able to plug that board right on. If you can send me the pin out of what you need and the connector type, well, I can see what IO I have.
Why can't you have the leaf hanging off the end?
The problem
Normally
is it's an M.2 connector, so you have to have something out there to bolt it to. You can't just flop it in the air, and it has to be coplanar with the board that it's plugging into.
Yeah, maybe
but
we could build a jig to hold things in alignment.
We just make the board extend out that far. I mean, we're only building 10 of them. So, I mean, if it's this big, it doesn't matter, right? So make it big enough to, if you want to do that. I just am trying to get this thing done quick and dirty. So if at the time I was first doing it, the leaf module was, I mean, the VLF board was way out in the future. It's come a long way since then, so. But I think
The
it might,
Blaze will do that.
yeah. But it might be useful, Jonathan, to have a place to at least plug on the board that you have. Because that's another problem, is that we have to build a leaf board, have a leaf board to plug onto it, and we don't have that. So if we've got Jonathan's board that he has today that we can arrange to plug on there, that might be useful.
Yeah, exactly. And that's the information, the part numbers, they are all in the documentation for the eval board, and I will get you that.
Okay.
The
Sounds like a simple change too, so.
yeah, it's not really all that bad. Actually, I was gonna make a little interface board that had that kind of connector that would act as a Raspberry Pi hat or a BeagleBone hat. And the lines, the signals that I sent to you a while ago in an email, those are the signals that you'd want to hook up.
Right. But you've got a board that you've made, right, with this connector on it, or are you bought?
Yeah, well, those signals are already on there. So
Well, they're already on your board, but they aren't on my board yet. So
yeah, no. But what I mean is, if you do have the extra I/O, and there's there's the I2C interface.
I know, I remember there's like about 6 pins or so.
Yeah.
That we need to have. Yeah.
If you have it, but in the meantime, I will send you the information and the part number, and you could just let me know if you could do it.
Of course, I have to be able to buy the connector too.
Yeah, well, when I checked a couple months ago, DigiKey stocked it, of course, but you know, that could change now.
Do you know how many pins there are?
I believe it's 20.
Yeah, because I know there's different size Mictar connectors.
Yeah, it's 20 or 24 pin, something like that. It's not very big. It's just a little wide.
Yep. And then I know what you're talking. It's got that zigzag thing down the middle that's ground.
Yep, exactly.
Yeah. Okay. Send me that info. We'll see what we can do and get this wrapped up.
Okay.
Thanks.
Hey, Jonathan, I got a 3D printer for Christmas. I about got figured out if you need something 3D printed.
Well, I appreciate that. I do. There's about 14 parts for a vertical seismograph. It's one of the first of its kind. It's currently under development, and what I wanted to do was I wanted to build one to actually test it and use it. It's actually pretty usable now. There's about 14 parts. I will send you the link to the files.
Okay.
And if you'd like, I would definitely appreciate it. You're also welcome to build one yourself and start playing around with some amateur seismology too, if you want to do that.
Yeah. Have to wait for my current 20-hour print to get done printing, and I try that. Send me something at naet@woh.rr.com, and I'll take a look at it.
Okay, thank you.
So, Jonathan, this is the connector you're talking about, right?
Yes.
Okay. Well, if it's a 28, which seems to be the smallest one they make, they got some. And I think that's the mating one. I don't know which side they don't mate with each other. They have a top and a bottom. So
right, yeah.
That looks awfully familiar.
Yeah, Motorola used to use on a lot of their.
What's the same thing that's on the Max 10 board?
Yeah. Actually, that's an HSMC connector. It is a little different.
Yeah.
But
Boy,
same
looks
kind of
almost
technology.
identical.
Same kind of technology though, with the strap down the ground down the middle.
Right.
But this is the 28 pin one. This is the smallest one DigiKey showed on their list. So hopefully that's the size.
That's made by TE Connectivity. It looks.
I'm sure Semtech makes one too. This is just the one I picked.
Yeah, yeah, it is from Samtech. There, so the part number, or the part that you will use is actually on the evaluation module host board. So there's a host board that supports different evaluation boards for different parts, and that's the part that you'll be using. It's in the data sheet, so I will send you the information, and the schematics are in there too.
Yeah, so here is the, oh, that's a plug. Okay. Yeah, so getting the right part number is critical because there's tons of different ones. So we need the mating part one, mating part.
Yeah, I will get you the right one.
So, okay. Sounds great.
All right, thanks, Scotty.
Sure.
I have a question for Nathaniel. Nathaniel, the data that you use for working on the SuperDarn data, is that something you are able to download, or do you get that from them by talking to them? Because I looked at their website on data, and it said something about you need to talk to them to get SuperDarn data, but there's also a data download site that uses a special format that I'm not familiar with.
Yeah, so I get it directly from them. I have access to their servers, so I'm able to download it that way.
Okay, all right.
They I think there are some public repositories where you might be able to get it as well from different countries, but I don't really know. I think the best thing to do would be for either me or for Francis to give it to you. And you're right, it is in a different format. They have their own proprietary format called FitACF, and you have to have the right software installed in order to decode it and know how to plot it.
Right, and there's also a link to a software that they provide. You may have worked with it. Another site where you can go and get their software, their plotting software.
Yeah, so that's right. We're using the PyDarn plotting software.
Right. Okay.
Mm-hmm.
All right, because we still need to. I sent you something in the chat. I'm going to have a draft here soon, but I'm going to as you mentioned the other day, we need to redo the charts to be, to be high quality and consistent in format.
Right.
So, yeah. Anyway, I'm also going to give Dr. Adkison a copy. I just got to write the abstract. That's all that's left on on draft 1, and then I'm going to have him review it to clean up anything I've misstated on the machine learning side.
Okay.
So he can become
and
an
since
author.
we're using SuperDarn data, I will have to let the SuperDarn PIs know at Virginia Tech too.
Right.
And then see if it's appropriate, whether we just acknowledge them or add them as co-authors or something.
Yeah, I mean, there was something on the website about how to acknowledge their data, but acknowledge using their data, but talking to them is definitely the right way to go. So
yes,
yeah,
yes.
All right,
Absolutely.
I will not be on tomorrow's telco, but
that's right.
I'll have you another draft on this in a few days. So
great. Yeah, and I'll be busy writing yet another annual report tomorrow. So I feel like that's all I do is write annual reports.
Okay.
So, okay. That sounds great, Bill. Thank you.
I'm gonna head out. 73.
I'm gonna head out too.
Yeah, me too. 73, everyone.
All right,
night.
73.